represent nearly 1/2 of the productivity of the planet, and they are threatened. We know that by producing ever-increasing amounts of CO2, man is turning the climate upside down. Very recently, we've also learned the excess of carbon dioxide in the atmosphere modifies the chemistry of the deep seas. Oceans are getting more acidic. Their acidification leads us on an uncertain journey about which the scientific community is worried. It's a very special polar adventure indeed, which leads the Esperanza to sail on this 6.5 million square mile ocean, half of which is nothing but ice throughout the year. For 7 weeks, the Arctic Ocean is going to be a laboratory for 35 scientists, who have come to observe the impact of a phenomenon which has only very recently started to be observed, the acidification of the ocean. The International Scientific Base at Ny-Ålesund, northwest of Spitsbergen, is only 750 miles away from the magnetic pole. It's here that for the very first time, and under the initiative of the European research project EPOCA, more than 100 scientists from 9 countries and 29 organizations will gather around the first research program on acidification. Jean-Pierre Gattuso from the French Oceanic Laboratory of Villefranche-sur-Mer is the coordinator of the project. Ulf Riebser from the German laboratory of IFM Geomar in Kiel is the scientific manager of this experiment.
C'est un challenge pour la science parce qu'on est les premiers en fait à travailler sur l'impact de l'acidification dans les eaux froides et dans des milieux extrêmes comme ici. L'acidification des océans en fait est un processus que l'on connaît depuis longtemps. On sait depuis une trentaine d'années que lorsque du gaz carbonique est absorbé par l'océan, il rend l'océan un petit peu plus acide. Mais il n'y a qu'une quinzaine d'années qu'on a réalisé que cette augmentation d'acidité aurait un impact sur les organismes et les écosystèmes marins.
Carbon dioxide produced by humans is modifying the chemistry of the deep sea, even in this remote and icy universe.
On pense que l'Arctique va être une des zones qui va être touchée la première par l'acidification des océans. La raison est très simple, c'est que tous les gaz, y compris donc le gaz carbonique, se dissolvent plus facilement dans l'eau froide que dans l'eau chaude. Et donc dans l'océan Arctique et aussi dans l'océan austral, on part déjà avec un niveau d'acidité qui est relativement plus élevé que dans les zones tempérées et chaudes.
To study the reaction of marine organisms to our ever-increasing emissions of carbon dioxide, CO2, researchers are going to install these 55-foot-high metal cylinders called mesocosms in the fjord. It's taken 4 years for the German scientists of the Oceanographic Laboratory in Kiel to conceive and build these enormous test tubes. All sorts of languages are spoken on the wharf. Technicians and researchers are all bustling around. Within 1 week, the mesocosms must be anchored in the waters of the fjord at a freezing temperature of 33 degrees Fahrenheit.
Once it's in the water, we'll then lower the bags to the full depth, which goes then 15 meters into the water, and by sinking down it will just cut out a full column of water with all the organisms included in it. And once it has enclosed this body of water, 55,000 liters of water with many, many thousands of organisms in there, we'll close the bottom and then we can start manipulating the system by adding CO2. And we'll just have the different mesocosms, each of one representing a different time in the future. So we go 20 years into the future, 40 years, 60 years, 80 years, whatever we project in terms of CO2 rising in the atmosphere. And then we'll just, once we have that manipulated, we'll just watch it. Es ist eine Mischung aus Begeisterung. Ich bin begeistert, dass es losgeht, aber ich habe auch Angst, dass Dinge schiefgehen können. Wenn es jetzt irgendwie nicht klappen sollte, dann haben wir wirklich sehr viel Energie hineingesteckt in ein Projekt, ohne dass wir dann den Erfolg am Ende haben. Also es ist eine Mischung aus Freude und Angst.
So we have our own little lunch break here on the ship with nice chocolate bars and wait for you. Okay, we're getting a proper lunch, so enjoy.
We're just putting on what we call the tents, and the purpose of those tents is to not have seagulls fly into the mesocosms, because as they poop in there, of course, they bring in a lot of nutrients, which would then interfere with our experiment. The biggest threat we have is the ice. We can handle small pieces of ice, we can push that with our boat, but if it comes in a massive wall of ice just crossing our location here, there's little we can do about it.
At the moment we are filling this tank about 1.5 cubic meters with seawater, with natural seawater, which we pump from the fjord. And later on, when this tank is filled, we will aerate that water with CO2 gas. And by that we will acidify the water, really saturate it with CO2, and then use that water to inject it into our mesocosms. We do this to simulate future changes in ocean chemistry, especially ocean pH.
pH is a measure of hydrogen ion concentration. This is the universal index of water acidity. It's the pH value which shows the acidity or basicity of the water.
Une eau acide a un pH inférieur à 7. L'eau de mer a un pH qui est aux alentours de 8, donc elle n'est pas acide, elle est le contraire, elle est basique. Cependant, lorsque cette eau de mer absorbe du gaz carbonique, son acidité augmente, c'est-à-dire qu'on va vers des pH plus faibles. On pourrait prendre une analogie avec la température. Si par exemple dans l'Arctique, en hiver, il y a une température de moins 40 degrés, et puis le lendemain, il y a un événement météorologique, et on monte à une température de moins 20 degrés. On dira que la température s'est réchauffée. Pourtant, la température est toujours froide. Eh bien, c'est pareil avec l'acidification des océans. On va vers un océan qui s'acidifie, mais il ne deviendra jamais acide, son pH ne deviendra jamais inférieur à 7.
The stability of pH depends on the level of emissions of carbon dioxide, one of the most significant greenhouse effect gases. Oceans play a major role in the regulation of the cycle of CO2. When CO2 circulates freely between all the various components of life, atmosphere, soils, plants and oceans, marine organisms are able to come to a natural balance with the gas. But when it penetrates the oceans in too great a quantity, CO2 may bring death to the deep seas.
When carbon dioxide dissolves in water, when it's taken up from the atmosphere into the ocean, what happens is it forms carbonic acid. CO2 reacts with water to form carbonic acid. Unlike all other gases, oxygen and nitrogen and argon and so on, they dissolve in seawater, they don't react further with water. CO2 reacts with water and forms carbonic acid. The more CO2 enters the surface ocean, the more acidity we have in the water. This is in fact the process of ocean acidification.
Once it's been absorbed by surface waters, CO2 continues its route towards the depths of the ocean.
In the surface waters that receive the sunlight, you have algae, planktonic organisms that produce organic matter. This organic matter is then eaten by other organisms. So you have a whole food web here. And at the end, carbon is being transported to the deep. So it sinks down, and together with the organic carbon, we also have a sinking of planktonic organisms such as foraminifera, diatoms, and they have skeletons that fossilize. This whole process is called biological pump, and it basically consists of two words: biology, that's what's driving it, and the pump, because we are pumping carbon against its gradient to the deep sea. So there is more carbon in the deep sea than there is in the surface. That's why, in fact, without the biological pump, the PCO2 in the atmosphere would double within 200 years. So the biological pump plays an important role in controlling the PCO2 in the atmosphere.
The equilibrium has been threatened ever since the Industrial Revolution began. Within 200 years, oceans have absorbed